Welcome back. The objectives of this video is to study transformations using the natural log function. Some of this is just putting it all together. So the natural log of x, of course, is log base e of x. So I've taken the liberty to graph the natural log of x function. Okay, keep in mind that e is about 2.7, and so I was able to pick a couple of points. E1 is a point, and e squared 2, and e squared is about 7.5 is another point. So I've got these particular points that I can just graph for the natural log of x. But now for our function, our transformed function here, we've got a lot going on. We've got x plus 1, which means we're going to shift our vertical asymptote 1 unit to the left. So we have a vertical asymptote at 0. We're going to shift that to -1. And then the -2, the negative is a y, so this is going to be a reflection over the x-axis. Okay, because that -2 is a shift on it's a y change, so we're moving along the y-axis. We're going to reflect over the y-axis, or over the x-axis, I beg your pardon. We're going to move along the y's. So like this point here at E1 is going to reflect to E -1, but that's not accounting for the horizontal shift. And the 2 means we're going to have a vertical stretch of 2. So it might be helpful to write a new xy rule here. So our new xy rule, our x's are going to shift 1 unit to the left, so our x is going to be x minus 1. Our y is going to be a -2y. So for every x here, we're going to subtract 1 unit and do a -2y. So that one just shifts over. Now this one we're going to shift for the one at E. We're going to subtract 1, but then we're going to reflect it and then double that value. So now that would be like there. In this one, we're going to move 1 unit and reflect it and double it. So we are going to get a graph that looks something like there's our new vertical asymptote. That's going to look something like this. Let's see how close I came on my values here. So finding the domain of f, our valid x's are everything to the left of negative, or to the right of at -1. So from -1 to infinity. I've graphed my function f. The state, the range in the asymptotes, I have a vertical asymptote at x equals -1, and our range goes from -infinity to infinity. The only intercept I see is the origin. We pass through the origin, so we go through 0, 0. The function behavior in concavity, our function is decreasing, even though our average rate of change, or our rate of change, is actually increasing. It's becoming less and less negative, and this is concave up. And use limits to state the end behavior. The limit of f of x as x approaches -1, and we're approaching it from the right, we're coming at -1 from the right, that is going to positive infinity. And the limit of our function f of x as x approaches positive infinity as we're going to positive infinity, that is, the y's are going to negative infinity. In example 8, we're given g of x equals the natural log of 3 minus x quantity squared. Well, we can go ahead and invoke our power rule and bring the 2 down in front. So we get 2 natural log of 3 minus x, which really is the same. I always like factoring out that negative sign and make that the opposite of x minus 3. So we've got a couple things going on here with our x's. It looks like we're going to shift 3 units to the right, and then we're going to reflect along the x-axis, so we're going to reflect over the y-axis. So we're going to take our asymptote here, it's going to get shifted 3 units to the right, so we're going to have a new vertical asymptote at x equals 3, and this point here is going to move there to 4, but now we're going to reflect it back over this new y-axis, so it's going to end up at 2. Might be a little confusing, but we shift it 3 and then we reflect over, and so that point at 1, 0 became 2, 0. So I've plotted some additional points, which really isn't that easy, but I'm following our pattern. I'm shifting the black points, I'm shifting them 3 units to the right, and then I'm reflecting them over, and then doubling their y value height. So we do get a graph that does look something like that. So there is our graph of g of x. I've written my xy rule here. So find the domain of g. Well, we don't have any x's to the right of 3, so our domain goes from negative infinity to 3 non-inclusive. State the range and the asymptotes. I've got a vertical asymptote at x equals 3, and our range does go from negative infinity to infinity. Intercepts are a little bit more difficult. We definitely have an x-intercept at 2, 0. The y-intercept is a little bit more complicated. It's 2y, so when x is 0, y is 2 times the natural log of 3. The function behavior in concavity, our function is decreasing, but it's decreasing at a decreasing rate, and it is concave down. Use limits to state the end behavior. Well, the limit of our function g of x, and where x is going to approach our asymptote of 3, and we're going to approach it from the negative side or from the left, and that is going to negative infinity. And the other end behavior, the limit of our function g of x as x approaches negative infinity, so heading to the left, well, that is heading out to positive infinity. And there are a couple examples of transformations using the natural log, and you will get some more practice with that when I see you in class.